This lecture covers apothecary measurements. Apothecary measurements were used way back when in medicine to measure dosages for medications. It's not likely that you'll encounter them in medicine these days, but it's always important to know how to work with them in case you do. So there's several rules for working with apothecary measurements. The first is that any fractions of 1/2 are expressed as little s, little s. Lowercase Roman numerals denote numbers 1 through 10, 20, and 30. So for example, if you had a measure or a medication that was 3 1/2 grains, so this is the standard way of writing it. The number 3 in Roman numerals is 3 uppercase i's, but for apothecary measurement, they're lowercase i's. So this would actually be expressed as I, little 3 little i's, and the half would be little s, little s. So that's how you would express that for grains. And then the symbol is always placed before the quantity. So grains 2 means 2 grains. We're used to seeing our dosages calculate with the quantity before the measurement. But for apothecary, we put the measurement before the quantity. So how many milliliters are in fluid ounce 2.5? Or the way this should be written is fluid ounce little I s s. So 2.5. We're used to setting up conversions by placing the known on the left side of the equation, or the known or the conversion factor on the left side of the equation, and the unknown on the right. So for example, normally when we're using ratios to solve something like this, we would put our known, which is 1 ounce is equal to 30 milliliters. So that's our known on the left and our unknown on the right. So is equal to 2.5 ounces over X. And then we would cross multiply to solve. If you notice, when we set them up this way, we always have the same units on either side of the equation. So if we have ounces on top on this side, we have ounces on top on this side. If we have milliliters on the bottom, milliliters will be on the bottom here. When we set things up for dimensional analysis, the knowns and the unknowns are all on the same side of the equation. So for example, we always set it up as known times the conversion factor. So X over Y, whatever our conversion factor might be, is equals to Z. I always put the known over 1 just to remind myself that this is a fraction and I can work with it the same way that we work with all fractions. So if we are trying to find milliliters and we have fluid ounces, we start with our known. So fluid ounce 2.5. And I put that over 1 just to remind myself that this is a fraction. And I'm going to multiply it by the conversion factor. So we know that 1 ounce is equal to 30 milliliters. You can write it like this, or you could write it as 30 milliliters over 1 ounce. Either is accurate. When we're doing dimensional analysis, we want to choose the form of the conversion factor in which the units that we start with, so in this case, fluid ounces, will be on the bottom of the next conversion factor. So if we are looking at these two formats of the conversion factor, we have fluid ounces on the top here, and so we want fluid ounces on the bottom here. So we're going to choose this one. So 30 milliliters over 1 ounce. Or I guess I should say fluid ounce 1. And the reason for that is whenever you're multiplying two fractions together and there are a certain unit on the top of this fraction and a certain unit on the bottom here, they cancel each other out. So now we're left with, now we just multiply straight across like we normally do with fractions. So 2.5 times 30 is 75. And our fluid ounces canceled out, so we're left with milliliters. So 75 milliliters Now we multiply the bottom. So 1 times 1 is 1. So 75 over 1 is equal to 75 milliliters. So let's do this again. So we're going to use dimensional analysis to convert 48 milligrams into grains. So we're going to start with our known. So 48 milligrams, place it over 1. And now we're going to multiply by our conversion factor. So when we're going from milligrams into grains, we can either say grain I over 60 milligrams, or we can do 60 milligrams over grain I. Both of these are accurate, but we want to choose the one that's going to cancel out these milligrams. So we want milligrams on the bottom. So we'll choose this one. So grain I over 60 milligrams. So now the milligrams cancel out. And we multiply straight across just like we always do with fractions. So grain I is the same thing as 1 grain, right? So 48 times 1 is 48. And 1 times 60 is 60. And the units that we're left with is grains. So I guess this would actually be grain 48 over 60. And in order to make this correct, we have to reduce this fraction to its lowest form, which would be 4/5. So we're going to have grain, and the Roman numeral for 4 is IV over V. Grain 4 over 5. So sometimes you must take 2 steps in order to solve a problem. So for example, if we're trying to convert from 0.6 grams into grains, we only have a conversion from milligrams into grains. So first we must convert from grams into milligrams. So we're going to take our known 0.6 grams, place it over 1, and then we're going to multiply by our conversion factor. And so we know 1 gram is equal to 1,000 milligrams. So we need to set up this conversion factor so that gram is on the bottom so that the grams cancel out. So 1 gram is equal to 1,000 milligrams. So the grams will cancel out. You multiply straight across. So 0.6 times 1,000 is equal to 600. 1 times 1 is 1. The grams have canceled out. The milligrams are the units that we're left with, so 600 milligrams. So now we have to convert from milligrams into grains. So we start with our known. So our known is 600 milligrams. We're going to put it over 1 so that we remember that this is a fraction. And then we're going to choose, so we know that 1 grain or grain I is equal to 60 milligrams. We're going to choose the conversion factor of this that will put milligrams on the bottom so that the milligrams are canceled out. So 60 milligrams on the bottom, grain 1 on the top. So now the milligrams will cancel out. We're going to multiply straight across. So 1 times 600 equals 600. And then 1 times 60 is 60. We don't have milligrams anymore. We're left with grains. So we'll say grain 600 over 60, which reduces down to 10. So grain 10, or I guess it'd look more like this. Grain 10, lowercase, is our answer. So whenever you're doing this, always do the metric conversion first. So from grams into milligrams, micrograms into milligrams, whatever you have to do, but do the metric conversion first and then convert into grains. So whenever we're rounding in dosage calculations, and this goes for grains or standard dosage calculations, we always use leading zeros. So for example, if the dose is 0.5 milligrams, we write it as 0.5 milligrams. And the reason for that is if you were writing and you just put 0.5, a person could look at this and just see the 5 and not the decimal point, and give, you know, a much larger dose than was intended. If you have a remainder in your dosage and you're using the metric system, so milligrams, grams, kilograms, liters, milliliters, all those things, the remainders are always decimals. So you could have 2.5 liters or 1.25 milligrams. You're always going to have your remainders in a decimal form. If you're using household and apothecary measurements, the remainders are always fractions. So for example, 2.5 cups or 1.5 tablespoons. So for those things, you're always using a fraction as the remainder. So always round to the appropriate place numbers. So for example, for weights, we use kilograms, but we round up to the nearest, tenth. So 70.2 kilograms. If you have a syringe that is in tenths, then you're going to round up to the tenths. If you have syringes that are in whole numbers, you'll round up to a whole number. This is very important. Do not round until you've reached your final answer. And the reason for that is you can actually end up with a dosage that is much larger or much smaller than what you need. So carry as many decimal points as you need to until you reach your final answer, and then you can round up to whatever place you're supposed to round to. And do not use trailing zeros. So let's say that something is 1 milligram. You're supposed to give 1 milligram, and you write 1.0 milligrams, and someone misses this decimal place there. You can end up giving a dose of 10 milligrams when they were supposed to only get 1. So most of these rules are for patient safety. Okay, so pause your computers, work these problems, and then restart the computer to check your answer. So convert 30 milligrams into grains, and we're going to use the new way that we've learned to convert. So we're going to start with our known. So 30 milligrams is our known. We're going to place it over 1, and we're going to multiply by our conversion factor. We know that 1 grain is equal to 60 milligrams. We're going to set up our conversion factor so that milligrams are on the bottom, is equal to grain I. These milligrams will cancel out. And now we're going to multiply straight across. So 30 times 1 is 30. 1 times 60 is 60. And we're left with grain. So now we need to reduce this into its lowest form, which is 1/2. So grain 1/2, or grain little s. Now we're going to convert. So this is 3.5 into milligrams, 3.5 grains into milligrams. So we're going to say grain 3 1/2 over 1. And now we know that our conversion into milligrams is either grains on top and milligrams on bottom, or milligrams on top and grains on bottom. We're going to choose the one that's going to cancel out these grains here. So we're going to flip this conversion factor. So grain is on the bottom. So grain 1 is equal to 60 milligrams. So multiply straight across. So 3.5 times 60 over 1, right? Because 1 times 1 is 1. So 3 1/2 times 60. Our grains are going to cancel out, and we're left with milligrams. So first we have to convert this into an improper fraction. So 2 times 3 is 6 plus 1 is 7. So 7 over 2 times 60 over 1. We multiply straight across. So 7 times 60 is 420. 2 times 1 is 2. So 420 divided by 2 is 210 milligrams. So convert. So X is 10, V is 5. So convert 15 grains into grams. So we're going to start with what we know. So grain 15, place it over 1. And then we're going to multiply it by our known conversion factor. So we know that 1 grain is equal to 60 milligrams, but we want to put whatever unit we have on the top here, we want to put it on the bottom here. So we're going to do grain 1 is equal to 60 milligrams. And now we multiply straight across. So 15 times 60 is 900. And then 1 times 1 is 1. Our grains cancel out. And we're left with 900 milligrams. So we've got ourselves into milligrams, but we need to get into grams here. So we know that 1,000 milligrams is equal to 1 gram. So we're going to start with our known. 900 milligrams is our known. We're going to place it over 1 because we need to remember that it's a fraction. And then we're going to make this conversion factor so that the same units that are here on the top here are on the bottom here so that they'll cancel out. So 900 milligrams, we're going to put 1,000 milligrams here and 1 gram on the top. So those will cancel out. 900 times 1 is 900. 1 times 1,000 is 1,000. And our unit that we're left with is grams. So now when we simplify this fraction, and we're getting into grams, right? So this is a metric unit. So our metric units are going to be decimals. We're going to be left with 0.9 grams. So this was our 2-step conversion here.